Last lecture, we learned a lot about the parts of an atom and how to figure out the number of protons, neutrons, and electrons in an atom. Today, we're going to take that a step further, okay? So last time I just told you, hey, for just right now, we're going to say that atoms always have the same number of protons and electrons. And sometimes that's true, but sometimes it's not true. So when that's not true, the atom becomes now an ion. And so an ion is simply an atom that doesn't have the same number of protons or electrons. And this means the atom has a charge. Now, what do I mean by that? Let's take a look at our example of helium before, okay? Now, remember, we've got 2 protons here, and they have a positive charge, and 2 neutrons here. Do neutrons have a charge? Look back at your notes. They're neutral, so they have no charge. So we have 2 positive protons here in our nucleus, and we have 2 negative electrons moving on the outside. So we have a +2 and a -2. And if we take +2 and -2, if we do just a little bit of math, what does that equal? 0. It has no charge. It's neutral overall. Okay, it has no charge. But whenever we don't have the same number of protons and electrons, we're not going to have the same number of pluses and minuses, which is going to give our atom a charge. Okay, so when we're figuring out the charge of an atom, we only care about protons and electrons because neutrons don't have a charge. So we can just completely ignore the neutrons. We don't care about them. We're just going to look at our positive protons and our negative electrons, and we're going to count them up, and we're going to see, do we have more positives or more negatives, and that's how we figure it out. Okay, so we're going to look at a couple of different examples. Okay, let's figure out this atom. Well, first of all, let's figure out what it is. It's got 1, 2, 3, 4 protons. And remember, the number of protons is the determining factor in what an atom is. And so if we were to look on our periodic table, number 4 is beryllium. Okay, so this is an atom of beryllium. Cool. All right, so I'm trying to figure out the charge. Notice I've got 4 positive protons in my nucleus. I've got these 4 neutral neutrons, but we don't really care about those, right, because they're not involved with charge. So I've got 4 pluses in my nucleus, and I've got 1, 2, 3, 4 negative electrons. 4 positive electrons, 4 negative electrons, +4 -4, what does that equal? 0, that's right, this is another 0 one, okay? So this is not an ion, this is a regular atom. Protons and electrons are equal, there's no charge on this atom. Okay, let's try this one. Here's fluorine. Now, I didn't give you one with a drawing of the protons and the neutrons because there's a lot in there, so it's going to, get kind of crazy. But fluorine's got 9 protons and 10 neutrons. But remember, we don't care about the neutrons because they don't have a charge, so we don't really care. Fluorine has 9 protons, 9 pluses. And then let's count up our negative electrons. 2, 4, 6, 8, 10. Okay. So fluorine has 10 electrons and 9 protons. So there's 1 more electron, which means there's 1 more negative charge than there are positive charges. There's 1 more negative electron than there are positive protons, which means the charge of this would be -1, because there's 1 more electron, and that electron has a negative charge. Does that make sense? We're going to try a couple more. Okay, we've got an atom with 11 protons, 12 neutrons, and 10 electrons. What element is this atom? Okay, first of all, we have to go back to our periodic table. And if you don't have one, you can always just Google periodic table. I'll have one for you linked on PowerSchool Learning, but you can just pull one up. We'll be giving you a really, really nice periodic table whenever we see you in person. So if you were to look up number 11 on the periodic table, that would be sodium. Good. Okay. And now we're going to try to figure out the charge. So we completely ignore the neutral neutrons. So we have 11 protons and 10 electrons. Okay. So we have 11 positives and 10 negatives. So 11 minus 10 is 1. Positive 1, right? 11 minus 10 is positive 1. So we have a charge of +1. Great. Awesome. So one way to figure out the charge of an atom is protons minus electrons, right? And if the number is positive, then it has a positive charge. If the number is negative, like back over here, it has a negative charge. Remember if we do protons minus electrons, 9 protons minus 10 electrons is negative 1. Whereas here, 11 minus 10 is positive 1. Okay, so protons minus electrons equals the charge. Let's try our second example on this side. An atom is 8 protons and 8 neutrons. What element is this atom? Okay, well, look at my periodic table. Number 8 is oxygen, our good friend oxygen. Okay. And then I don't give you the electrons. I say, oh, the atom has a charge of negative 2. How many electrons does it have? Remember, charge is protons minus electrons. So 8 minus what number is negative 2? 8 minus what number is negative 2? 8 minus 10 would be negative 2, right? So it would have 10 electrons, would give it a charge of negative 2, because then I would have 2 more negative electrons than I do of my positive protons. Okay. Now, I want to put you at ease. You're not going to have to memorize these things. Later on in the year, you'll get really good with it, and you'll just know what some of their charges are, and we'll teach you a couple of tricks on how the periodic table has some of these ions grouped together. But basically, all you need to know how to do is, can you figure out what the charge is if I give you the number of protons, neutrons, and electrons? Or, if I give you the charge and the number of protons, can you figure out how many electrons that atom must have, that ion must have? And if you can do those things, then you have mastered the main ideas of this lecture.